Hello everyone, I'm Necrus.
Hello, my name is Ibrahim.
I'm Caden.
El Motaz.
And this is
Nice
Power Tracer.
This project was about power management in our homes. We made sure to implement different systems where people and users can manage their electricity usage in their homes. We wanted to show how they can save their money in electricity and also manage all the devices that are connected to our network using circuitry. We came up with simulation values and also real-time values. We built our own boards with our own components. And in terms of the simulation software, we developed it using Next.js, JavaScript, and custom components. We made sure to make it interactable and user accessible. So one of the things you can do is basically just drag and drop the tabs and connect your circuits and all these objects and run a simulation to see if it would hold up or not.
So running an example simulation for this, we're gonna start from the top. So to start first, you need a breaker, and you can have as many fuses you want to for it, and you control the ampere amount that it exceeds from each one of them, just for extra control. And even like if you want to change it in real time as well, you can after you get everything connected and you forgot. So we can get some stuff going here where we can set up an outlet connected to a light and then have also a breaker connected directly to a device. So for a 120 volt, we're gonna connect it to a 120 amber, but for the sake of this project, I'm gonna mix it with the 240 to show some of its conflictions. If you do use the wrong connections, it does give you a real-time feedback once you run the simulation. We're going to connect this 120 volt directly to the light and run the simulation. As you can see, there is an issue. If we scroll up, it gives you a little bit of the voltage mismatch on this is because this is a 120 volt. So if we were to go back a little bit and get a 240 volt right here and delete that, connect it through the 240, and then delete this as well, connect this to us to a 240. And then clean this up while we're at it. Bam. Make it more realistic, you know. And there you go. No issues detected. It gives feedback on each of the circuit's fuses, which one is being in use, and the output of it. So, thank you.
Hello, everyone. This is our circuit that we use to monitor a real-time current through a device. As you can see here, we have a LED connected, so getting supplied by a microcontroller. And here we have the sensing device, which is sending the current measurements to our interactive dashboard. And so essentially the sensor um, uses a shunt resistor that that measures the voltage drop between the LED. And yeah, that's all that we have.
All right, here is the code behind our ESP32 Arduino. So first we decided to use, we tried at first to use WebSockets, but we learned that when we deployed our app fully, Vercel does not allow live WebSockets. So we instead turned it to an HTTP GET post request to send our current data. So first our ESP connects to the Wi-Fi. We're using just the one GPIO pin to detect the voltage. We've made a little helper for setting up the Wi-Fi. So we set up our board, set up our pins. We try to connect to the Wi-Fi and wait and give us some feedback on while that Wi-Fi connection is happening. And once it's done, we do our main loop where it checks if Wi-Fi is not connected, then we don't continue. It restarts the loop. We read our raw data voltage from the analog pin. Then we have to convert that to the actual real voltage because it gets it in a 12-bit interpretation of the voltage. Then we calculate the current by that voltage drop divided by our resistance of our shunt resistor. And then we did some smoothing so that in case there were any jumps between the currents from one point to the other, it would be like kind of like an exponential growth and then depend on the past data in case there's any weird jumps or never goes high or low. And then we just build a JSON data packet where we send the ID and the current to our front end. And then here we just have the HTTP request where we send it to our live hosted app. And that's all at the end of the Arduino code.